Okay, so we want an antiderivative of the square root of t with respect to t. Helps if we write this as t to the 1/2 because that makes it clear that this is a power function, right? Now, one thing that somebody said, well, you're going to get t to the negative 1/2. Well, that's absolutely the right type of thing to be thinking of. You're going in the wrong direction, but that's the right idea because now you're in the context of power functions, and you know that when you take the derivative of t to any power, the power is going to decrease by 1, right? But now we're doing antiderivatives, so the power has to increase by 1, okay? So, the power is 1/2. It's got to increase by 1. So when you take its derivative, you get back the original power. Does that make sense? So it must be t to the 1/2 plus 1 equals t to the 3/2, or a multiple of t to the 3/2. And I should say a constant multiple because there are all kinds of multiples, right? Well, what constant multiple would that's t to the 3/2, not t to the 3/3. What's the derivative of t to the 3/2? What is it?
T to the half.
That's going to be, it's going to have a t to the 1/2 because the power's got to go down 1. What's the derivative of t squared? 2t. Where'd the 2 come from? It's the power, right? Well, if you think about it, you see it's got to be 3/2 t to the 1/2, right? It's the power times 1 less power, right? And hopefully you know how to prove that, or at least have some idea how it's proved, at least for integers, okay? So the derivative of 2/3 of t to the 3/2 is going to be what? 2/3 of the derivative of t to the 3/2, right? Which is 2/3 of 3/2 t to the 1/2, right? And what's that? What's 2/3 of 3/2? 1. So that equals just t to the 1/2, right? So from all this, we see that antiderivative of t to the 1/2 has to be 2/3 t to the 3/2, right? Okay? And you can easily verify the derivative of this is t to the 1/2. But this is the reason, okay? So what do? I could write it as a formula, but better to just understand it. And then when you see the formula, you know what it means, okay? You just raise the power by 1/2 and figure out what multiple of that you need to get the original expression, right? Okay? And that's very easy after you do it a couple of times. Okay? And there's a formula you can use. It's in your book. You can look it up. But I don't think you need it. Okay? If you understand this, I don't think you're going to need it. And then if you can do these without looking at that formula, then that formula is going to be very helpful to you. and you understand why the formula says what it does. Okay? So let's see if you can do these problems. Oh yeah, what? Before you go on to the problems in the sheet, see if you can figure this one out.